The Composite Materials page allows you to examine the effects of hypothetical filler materials on packaging performance. The Composite Materials page allows you to create inorganic, impermeable fillers that can be blended into polymers. The model assumes that there is perfect filler-polymer interaction and that there is no voiding around the particles that could affect the modulus or barrier enhancement properties afforded by the filler. The model also assumes perfect dispersion of the filler material and that the additive has no other impact on the polymer, such as changing crystallization behavior. Of course, in real life, we know we can't rely on these assumptions. Therefore, the Composite Materials creation page should be used as an exploratory exercise to provide insights into your R&D programs. Like creating a polymer blend, when you click on Composite Materials, you are given the option to choose the existing nanoclay default or add your own composite. Let's click Add. First, let's rename our composite material name to something that makes sense. And you'll want to get in the habit of doing this in various places throughout the model. The last thing you want is a bunch of custom materials that you can only identify by the date that you created them. You have 3 parameters that you can adjust for your custom composite. First, there is density, which is grams per cc. Typical densities for inorganic fillers are in the range of 2 to 4 grams per cc. So let's set this at 2. Next, you can set your modulus. The modulus refers to the stiffness of your composite. Keep in mind that the tensile modulus for many inorganic fillers is 10 to 100 times greater than that of most polymers. So it doesn't take a lot of filler to substantially increase the modulus of your polymer. Our custom composite has a modulus of 2. Finally, we can plug in our aspect ratio. The aspect ratio of a composite material is defined as the length to thickness ratio of the individual particles of the composite. The greater your aspect ratio, the greater the impact a given amount of the additive will have on your polymer's barrier properties. Our aspect ratio here is 130. Click Save. We can now go back to the Polymer Blend Creation tab and choose our 56% monoxide blend that we recently modified. Now when you click on Choose Composite Material, you have the option to select the new composite we just created. We'll need to adjust our ratios to make room for the filler in our blend. So I've set my nylon MXD6 to 54%, my PET to 44%, and my new filler to 2%. Finally, we want to make sure we rename this. I'm going to do that by typing in a new value next to Save As. Once I've typed in the new name, I'll hit the Save As button. You'll note that there is one last tab in the Polymer Blend Creation section of the Emerald model, and that is the Polymer Modification tab. Please go to the next video, Polymer Modification, to explore how to use this tab.